Hey everyone, Chang here and welcome to my channel. Now, every now and then you're going to encounter problems or situations where they ask you if a certain number is prime or not. Now, if it's a small number, fairly simple. If we have Google, of course, lovely. But in cases where it's not a small number, like we don't have Google, then it actually becomes kind of daunting. Because guess what? I guess you could say the standard way that we would probably approach it is like, oh, well, I guess I got to try every number and see if that number that we're testing is divisible by any of these numbers. Well, that's not necessarily true, right? There is a sort of strategy to go about it. There's an interesting shortcut just from noticing patterns, right? So I'm going to use these two as an example. We're not going to go into any large number, just to let you know, but hopefully with this you guys can see something very interesting. Then we're going to test this one, of course. So first and foremost, when you're trying to figure out divisibility of a number, if you're trying to figure out if it's prime or not, what we're really trying to do is, well, divide, right? Figure out factors of that number. So let's look at 81. If we're looking at factors of them, well, the first one we see is, of course, you got 1 and 81. And then afterwards, we try to test out the numbers, so on and so forth, right? 2, does it work? No. 3, does it work? Yes. So it's going to be 3, it's going to be 27. 4, does it work? No. 5, does it work? No. 6, no. 7, no, so on and so forth, until we reach 9, which, yes, it works. And then afterwards, something interesting happens. After 9, right, and we keep testing, the next one is going to be 27, 3, 81, 1. Right, notice that. We have this sort of what we call a midpoint or halfway mark, right, where after that, it is the same thing except for things just flip, right? So notice that after this, these guys trade places, these guys trade places. That's all it is, right? It's nothing new. Well, this is a special case because this is what we call a square number, where basically you have a number that multiplies itself to become that original number. Well, this is not a square number, but something interesting happens. When we start breaking down the factors, and we try to be organized, of course, right? So we have 2, and that's going to be 26, and then 3, does it work? No. 4, does it work? Yes. So it's going to be 4, it's going to be 13, and then we keep going, and eventually we're going to get to a situation where it's basically 13, 4, 26, 2, 52, 1. Now, unlike this square number, where we can see exactly the halfway, right? There's no interesting pair that's exactly halfway, but we do see that there is a situation where eventually it ends up flipping again. So using this understanding, actually we find out that if we look at a number and we take the square root of it, right, that gets us really close to the halfway. Sometimes the square root might not be a whole number, but if we take the square root of it and afterwards all we have to do is test the numbers up to that square root, right? If any of the prime numbers up to that square root can divide into that original number, then, well, ta-da, it's not prime. Simple as that. But if all the prime numbers leading up to that square root, right, cannot divide into that original number, then it's prime. And we don't have to waste our time testing out the other half. So now that we've seen this, notice two things. First and foremost, always try to find the halfway. Take the square root of the number. It might not be whole, but just take the square root of it, right? And then afterwards, list all the prime numbers that are close up to that square root and then start testing them. Some of them, there's creative ways to just very quickly figure it out, and some of them you just have to divide and see, right? So knowing this, let's try to actually solve or figure out if this is prime or not. All right, so here we are. I've erased everything so that we have 181 right here. Now, I'm talking about situations where you don't have a calculator, so trying to figure out the square root of this guy is not great. But let's just start finding numbers and seeing what it's close to. Well, if we look at 13 squared, we know that's 169. Hopefully you guys are familiar with that. If not, you know, we can test it out. If we look at 14 squared, that is, what is that, 196 actually? Yes, right? So that's 196. Now, that's super interesting, right? So if that's the case, the square root of this guy right here is going to be somewhere between 13 squared and 14 squared. So if we list all the prime numbers, 2, 3, 5, 7, 11, 13, right? And see if it can divide into this guy. If it can, then, well, guess what? This is not prime. If it cannot, then all of a sudden we know that this guy is prime. Now, luckily for us, we know divisibility rule for a good portion of them. And if not, we can always just test it out, right? So, let's do this. First and foremost, 2, definitely not. 3, definitely not. 5, definitely not. 7, there's a divisibility rule for 7. But in situations where we're under high stress and we're not entirely sure, just test it out. 181 divided by 7. Well, 2, right? That's 14, 41, definitely not 7. Boom, just like that, right? And then we can do 11. 11 goes in here one time. Well, let's just look at 181 without that confusion, right? Let's just do 11 right here. 11 goes in here one time. That's 11. Subtract, and then we have 7 and 1. Nope, that's not divisible by 11. And then 13. That's the last one we have to check. 13. So that's going to be 181. Goes in here one time. 13. Subtract. That's 51. Can 13 go into 51? No. Right? So if that's the case, then this right here is prime. All right, let's look at the next one. We have 391 here. Well, if we think about what's the closest square number that can get us close to 391, let's just look at 20 squared. 20 squared is 400. That's pretty darn close to that. Well, that means we just have to check all the prime numbers that are less than 20. Well, that's going to be 2, 3, right? 5, 7, 11, 13, 17, 19. Okay, those are the numbers we have to check. And luckily for us, we know that this is out, this is out, this is out. We can very quickly verify if this is out as well, because 7 goes into 39, was that 5 times? 5 times, that's 35, so 4, 1, 4, 1, 7 can't go into 41, so gone. Right, 11 goes into here, what, 3 times, that's 33, so then what we have left is 61, that's gone. 13, well, 13 goes into here how many times? What, 3 times? That's 39 already. And then you have 0, 1, that's definitely not going to work. So, 17, well, at this point I can't really do that much mental math. Let's just show it out. 17 goes into here 2 times, that's 34. So we have 51. Can 17 go into 51? It can, huh? Because 34 plus another 17 is 51. So that's actually 3. And that's 51. Boom. There it is. Not prime. All right, so let's look at one more. This one, the obvious sort of square number that we can think of is not really, I guess you say, in our place. We can't really see it right away. But let's just look and test it out. Well, let's say 16. What happens if I times 16 by 16? Well, here's your standard way of multiplying, so you guys can see it. That's be 6, 3 right there. That's going to be 9, 0, 6, 1. There it is, right? That's going to be 6, 5. 1 right there is 2. 256. Okay, so, it doesn't work great. 17. What is 17 squared? So that's going to be 9, 4 right there, 11, 0, 7, 1 right there, 9, 8, 2, 289. Okay, that's pretty darn close. So 17 squared is basically pretty darn close to 287. So we want all the prime number that is less than 17. Well, if that's the case, that's going to be 2, 3, what's that? 5, 7, 11, and we still want to continue. 13, 14, 15, 16, 17. Okay, so we want it all less than 17. So there it is. All right, so then we just start testing out numbers to see if it works. Well, luckily for us, once again, we can see that this one and this one and this one does not work, right? 7, we can see right here, actually does, right? 7 goes into 28 4 times. Then after that, you have one more, which 7 can go into, and there it is. So this number is not prime as well. All right, so there we have it. Notice that we actually saved a great deal of time, right? A number like this, although not drastically big, if we were to approach it just trying to figure out numbers randomly, I mean, it's going to be tough. That's a lot of numbers to test out on 287. But with this strategy, understand that we're getting as close to the square root of this number as possible. And because we don't have a calculator, I'm using these kind of methods to sort of estimate as close as possible. Notice that this is smaller. This is really close, but a little bigger. So we know that the square root of this number is somewhere between 16 squared and 17 squared. So from there, we test all the prime numbers that is smaller than, well, our limits, right? Our biggest squared number. Why do we test only the prime and not the composite? And I feel like I failed to mention this in the beginning of the video. The reason we test the prime and not the composite is because guess what? Composite is just smaller multiples of prime. So for example, right? Why do we not test if 6 work? Well, we know that 6 is just 2 times 3. So if we can show that it's not divisible by 2 or divisible by 3, then it's guaranteed it's not going to be divisible by 6, right? Just that understanding takes out all the composite numbers, and then all we have to do is just test the smaller primes. And if we test the smaller prime, and if it's divisible, then, well, it's not prime. If it's not divisible, then it is prime. Simple as that. Just a fun little trick in case you ever encounter a problem where they ask you if it's a prime or not, you cut your work in more than half, right? Thank you for watching this video. Please like, comment, and subscribe. Hopefully you find this helpful, or at least pretty cool and enjoyable. See you in the next video.